Welcome back to the Calculus Lecture Series. In this video, we're going to be going over trig derivatives. Now, trig derivatives are a little bit unusual, right? They don't follow the same rules when you take the derivative itself. Now, for example, we have here, and we'll get to this problem, we have secant of x times cosecant of x. Now, when you take the derivative of that, the overall derivative follows a product rule, right? That's a term times a term. But taking the derivative of the function itself, like if this was u, if secant of x was u prime, it wouldn't just be the arbitrary like chain rule or the power rule. It's a little bit different. So I have here a simple rule that I've set up. If we have some trig function raised to an n power, now that could be the first power, the second power, the third power, you get the point, of some variable x in the brackets of that, right? It's a little bit different. Instead of just, you bring the power down, of course, you do the power rule of the overall function. So you can kind of ignore this. So for example, if this was sine 2 of x, okay, the first part of this would be 2 sine of x. However, if you made this sine of 1 to the x, so just sine of x. Well, when you do the power rule, what you'll notice, and I don't want you to get confused when we get to this point, we bring the power down, 1 sine 0 of x, and anything to the 0 power is 1. So no matter what we plug in here, it's always going to be 1. So this is 1 times 1, which is equal to 1. Okay, so I don't want you to get confused when we get to that point, because when f prime of x, the first thing you do is you do the power rule of the overall trig function. And if you don't have a power, say for sine 3 of x, it just kind of drops out that part. It's times 1. Well, then you take the derivative of the trig function, so just the trig function, ignoring the power and ignoring what's inside here. So, for example, and I actually have some givens for this. In your class, you will 100% be given these here. And probably a little more too, like say for example cotangent or the derivative of tangent, stuff like that. You'll probably be given a whole sheet. So we take the derivative of the trig function, and then we take the derivative of the inside portion of that trig function. So let's just get right into it here. I'm going to show out all the math, and I want you to just see, because I could easily just tell you that the sine of 3x is 3 cosine of 3x, right? I could do that, call it a day, but I'm not that dick of a person. We are going to work through it. So let's follow the rule of which I've put it up there. Okay, so let's do the power rule. So we know that this is sine 1 to the 3x, so I'm going to write f prime of x is equal to 1 sine to the 0th power of 3x. Okay, so that looks a little funky. We will actually simplify that later. We're going to put this in a bracket because we're going to multiply by the derivative of the trig. Okay, so we're going to find the derivative of just sine of x. Okay, so if we look here, the derivative of sine of x, of any x, is cosine of x. So this is actually multiplying by cosine of 3x. We keep the inside portion the same. And then we take the derivative of the inside, the x term. Okay, so we go inside here, and we take the derivative of that. Well, the derivative of 3x is just 3, so it's times 3. Okay, now we can do some simplification of this. So we say that f prime of x is equal to 1 times, and sine to the 0 of 3x is 1, because anything to the 0th power is 1. So this is equal to 1 times cosine of 3x times 3. We can combine terms here. 3 times 1 is 3, so we have 3 cosine of 3x. That is the derivative of sine of 3x. Do you kind of get what's going on, right? We took the derivative of the overall function given a power, but it dropped out, right? So let's see an example of when it doesn't drop out. Here we have sine to the third, 5x squared minus 3. let's do the power rule first. So we're going to bring down the 3 sine of squared, right? So it didn't drop out this time. It's not going to 0, it's going to 2. Now we say 5x squared minus 3. And let me just make sure that you guys can see this here. Gonna move us over. Awesome. Okay, so we have 3 sine squared of 5x squared minus 3. Okay, and now we take the trig derivative. So the derivative of sine, of any sine function, is cosine. We do not keep the power here. That's an important note as well. We're just taking the derivative of the trig with respect to its function inside. So that would be cosine of 5x squared minus 3. Okay, so we have that portion there. And then we have to take the derivative of the inside. So that's 5x squared minus 3. Well, we know a constant of 3 will just drop out, but the derivative of 5x squared is 10x, okay? And we know that this is equal to f prime of x. Okay, so to put it all together, f prime of x is equal to, and we'll multiply the 3 and the 10 here to give us 30x. We're going to then do sine squared of 5x squared minus 3 cosine of 5x squared minus 3. So that's the derivative there. All right, so it can get kind of complicated and tricky, and as we'll see with the next problem, that is much the case. So I'm going to move us back once more so we can see, because we're going to need the helpful givens here for problem number 3. So looking at this, this is where, remember how we did the product rule here, two multiplied terms. It's a little hard to multiply secant and cosecant together. So the product rule is quite unavoidable here. So let's define our variables here. So we will say that u is secant of x. The derivative of secant of x is, can you see it? Secant of x, the derivative of that is secant times tangent of x. I won't bother going through any proofs of that, but they're given values to you and stuff that you should know. So v is going to be equal to cosecant of x. So the derivative of cosecant of x is negative cosecant of x cotangent of x. So v prime is negative cosecant of x cotangent of x. I hope I don't sound like a freaking alien saying all this. I probably do. But anyways, that's what we're given for our variables. Now we need to plug and chug. So secant, so we're going to do u times v prime first. So secant of x, and maybe I'll go over here. Secant of x, so f prime of x is equal to secant of x times negative cosecant x cotangent x. And then we're going to add that to u prime secant x tangent x times cosecant x. Okay. So we could do a little bit of simplification, but this is probably the most simplified form. Just know bring your negative out and you're all set. So that is the derivative of secant x cosecant x. And that's trig derivatives. They're a little bit tricky. I suggest doing a bunch of problems and remembering all the rules for that because it is quite important. I hope you guys enjoyed this video. If you did, make sure to join us in our next one where we go over what's called implicit differentiation.